Welcome everyone to Advent of Code with Pandas. This is day 15. So here is my input data, which is sensors and their closest beacon. We're given coordinates to each. What I've done here is extract the coordinates, and I've done so not in read CSV, which I just read in every line as one piece of data. So notice capital X is the separator. That does not appear in the line, so it just reads in this whole line as one string. So instead, I've parsed it with extract all, which allows me to write a regular expression of any number of digits. That's what this \d is over here, plus. So that looks for any number of continuous digits that are possibly preceded by a dash. Okay, so I want to make sure I get negatives also, not just positives. So it'll read in 4 numbers per line. And then I'm going to unstack this because it actually just by default, it stacks the results. And I'm just going to rename those columns. So I get those 4. Finally, I create the Manhattan distance. So this is just the absolute value of the difference in x's plus the absolute value of the difference in y. So that's how far the sensor is from the beacon. All right, so part 1 wants us to find all of the x coordinates along the line where y is 2 million. So think of a line at 2 million in this grid. And we want to find all the x coordinates such that they are closer than one of these beacons to one of these sensors. All right. So for instance, let's just say we have a line at, I don't know, 0, 2 million, right? 0 the x, 2 million of the y. We can check how close it is to this first to this first sensor, right? So we know where the y is, know the x is. We calculate the distance. If it is less than this distance, then we want to keep that and say it is one that is actually closer than this. All right, so we have a little function that's going to go through every single one of these sensor beacon combinations and figure out all of the x's such that the distance is less than from the sensor to the beacon. All right, so the way this works is, this is going to be called, yes, on every row. I'm going to pass in y of 2 million. So we're doing axis equals 1. So we're given this row as a series. And what I'm going to do is find the distance from this to 2 million, the absolute distance. And then what I'm going to do is I'm going to grab this distance and figure out what is left over, right? So I need... I'm first calculating the difference here. I want to see if there's any distance left over such that I can even use any x's at all, right? So I'm going to figure out what distance is left over. If there is any distance left over, I'm going to create a range object over here that's going to look to the left that distance and move to the right that distance and collect all of those into a set, right? So it's going to just collect them all into a set and update that set. So it's going to continually add all of those x coordinates that where the distance is less than this. Okay, so it could be a lot. It could be millions of numbers over here, left and right, that are possible, especially if there's like a large distance between that point and the nearest one. All right, so that's what I do here. And then I'm just updating the set. So the answer is to just get the length of this set. How many total x points are, where that's true. I do have to subtract 1 because I cannot include any beacons on 2 million. There's only one beacon on 2 million, although there's 3 rows. It's just the same beacon that appears 3 times. So I do have to subtract 1 for that. All right, moving on to 15b, which was much trickier. So in this question, you have to find, there's one beacon that is hidden. So one beacon where it's like the second nearest to at least, or it is not the nearest to any of these, right? So this is just the nearest or closest beacon. There's one beacon that's available that's not closer to any of these. It's not the closest one. So we have to find that particular one. All right, so the way to do this is, there's probably a number of ways. I chose actually a particularly slow way. What I have done is I've looked at the boundary, one outside of the boundary. So between each sensor and the beacon, that create anything that's within that distance, we don't have to check. What we do have to check is outside the boundary, right? So any beacon that's further away than the closest beacon. So just one outside the boundary, and there's only one, we're given that there's one point in this whole grid that where this beacon could possibly be. So what I did was I just collected all of the boundaries. So I went through one at a time. Let's just go ahead and look at the head again. So I looked at every row at a time. I calculated the bottom right-hand boundary as a range over here. The top right, bottom left, and top left. So I created all these as actually I zipped together the X and the Y. So I found those boundaries, and I'm looking just one outside of those, right? So not right on the boundary, because that will be equivalent distance. The distance has to be one more. So I got all of these. So all of those boundaries from those sensors for each one. And then I return them as a list of zipped objects. So there's a lot going on here, I know, but these are just a list, basically just a sequence of points that are along the boundary. And then I just have a function that I've done here that will, first of all, it'll just get all of these zipped objects for all of the boundaries. So because all boundaries, right? So I get them all. And then what I do is I just iterate through all of those boundaries. These is just a list of zipped objects. I finally extract the XY coordinate of the boundary. It does have to be between 0 and 4 million, so that's one of the stipulations. And then what I do is I calculate the distance between that point and every single sensor. So that's what this is doing. So every point is checked against that sensor, and then this is how I find the distance, right? So this is just getting the absolute value between the X and the Y. I sum it up over axis equals 1. That's horizontally, so I get the Manhattan distance like that. And then I test it against the distances over here. So this is, an array of all the distances. And if it's greater than all of them, so if all distances are greater than the nearest beacon, then I know I found that one point and I can return it. So this one actually takes about a minute on my machine. There's a much faster way to do this. You don't have to test all the points, right? You don't have to skip through. You can actually skip points. So if you know that, there's still, say, 1,000 in distance of wiggle room, you don't have to check the very next boundary point, because at most you're moving away a distance of 2 each time. So this one checks every single one, which is unnecessary. You can sort of hop down, so you can go from up here to down here and know that you'll still be within the whatever the minimum distance was, like that. So anyways, this one was a really tough problem. You have to figure out a way to iterate without blowing up your machine. So this is one way that just barely works. And but if you did were able to hop around these points and not do every single one, you could cut considerable amount of time. All right, so that's it for Advent of Code with Pandas, day 15.